Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. Picture this. A student sees a final price and thinks, I'll just subtract 15% to get the original. They lose marks. Fast. How do we actually get the original price after a 15% increase? Stick around. I promise a simple fix you can use in every exam.
That happens to me all the time. I panic and try to undo with subtraction, and it goes wrong.
You're not alone, Maya. Let's break it down step by step so it becomes automatic. Today, the multiplier method. Convert the percentage to a multiplier, then divide to undo. No trickery. Just the logic of undoing a multiplication. Start with one clear idea. A percentage change is multiplication. If a price increases by 15%, the new price is the original times 1.15. If it decreases by 20%, the new price is the original times 0.80. So to go backwards, we divide by the same multiplier.
An item is sold for £138 after a 15% increase. What was the original price? Let's call the original price X. After the increase, X times 1.15 equals 138. To find X, divide both sides by 1.15. X equals 138 divided by 1.15 equals 120. So the original was £120. Notice we didn't subtract 15%. We divided by 1.15.
So the rule is convert the percent to a multiplier, like 15% becomes 1.15. Then divide. That feels much clearer than trying to take 15% off in reverse.
Exactly. Quick algebraic justification so it sticks. If original equals X and percentage increase P%, then new equals X multiplied by 1 plus P over 100. So X equals new divided by 1 plus P over 100. For a decrease, replace the plus with a minus. This is the same tidy idea every time.
Note for candidates, state the multiplier clearly and write the equation. Examiners award method marks for showing new equals original multiplier by multiplier, even if the final arithmetic slips.
Let's talk about where the marks are. This is the exam technique you need.
A typical 3-mark reverse percentage question is marked like this. M1 for setting up the correct multiplier equation, M1 for using a correct method, usually dividing by the multiplier, and A1 for the correct numerical answer with units. So even if you can't finish the arithmetic perfectly, write the setup and you can still score marks. Write X times 1.15 equals final, or original equals final divided by 1.15, and you've taken the first mark.
That's reassuring. So writing out the equation is real money in the exam.
Yes, and a couple of examiner tips. Label units, pounds, percent. Show the multiplier conversion, 15% to 1.15, and if successive changes are involved, show them as chained multipliers. Examiners look for clarity. The method mark is for the clear method, not mental gymnastics scribbled out of context.
Quick win. A 10-second checklist you can read before every percentage question. 1. Convert the percent to a multiplier. 2. Ask, was it an increase or decrease? 3. If working backwards, divide by the multiplier. 4. Label units and check by reapplying the percentage to your answer. Do this each time and you'll catch most errors. Don't skip the check.
Any mental shortcuts for exam speed?
Yes, for small percentages you can approximate quickly. 5% is a 20th, 10% is a 10th. So 15% is 10% plus 5%, 1.15. For reversing, think divide by 1.15. If the numbers are friendly, you'll spot the original quickly, but for accuracy, always show the division on the page.
Now, let's run a worked successive example, because order matters, and exam questions love to hide that trap. Suppose an item is first increased by 15%, then decreased by 20%,
and the final price is £92. Find the original price. Approach. Write the multipliers in order. Increase 15% times 1.15, then decrease 20% times 0.80. So final equals original times 1.15 times 0.80 equals original times 0.92. To work back, original equals final divided by 0.92. So original equals 92 divided by 0.92 equals 100. The original price was £100. Notice that multiplying the multipliers first gives a single combined multiplier, here 0.92, making the reverse step straightforward.
Mark scheme note: M1 for writing the chained multipliers, M1 for dividing by the combined multiplier, A1 for the final value with units. If a candidate divides by 1.15, then multiplies by 0.80, they will lose marks because that reverses the order incorrectly. Show the combined multiplier or reverse in the correct order.
So you can't undo one step and then undo the other in the wrong order. You must divide by the total multiplier or reverse the operations in the right sequence.
Exactly. Quick practice. Try these two now. 1. A laptop costs £276 after a 15% increase. What was the original price? 2. A jacket sells for £88 after a 12% decrease. What was the original price? Pause this episode, set a timer for 2 minutes and try both. I'll give answers after a beat.
Answers. 1. 276 divided by 1.15 equals £240. 2. For a 12% decrease, the multiplier is 0.88, so 88 divided by 0.88 equals £100. Marking note. Write the multiplier and the division to secure the method marks, even if arithmetic slips.
Those felt quick when I wrote the steps down. The check by reapplying the percent verifies the answer. Final recap in one sentence. Convert the percentage to a multiplier, divide to undo, label units and check by reapplying the change. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable cheat sheet with practice questions at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.